and welcome to this Mastering the Machine webinar for October the 19th, 2024. Our topic today was trainers, gadgets, and Gennflex, which was a trip that I made this week to Chicago to see a vendor for my new enclosure model. Hope you enjoy it.
Good morning, ladies and gents, and welcome to this, the 79th consecutive Mastering the Machine webinar for the 19th of October, 2024. And today I'm going to be talking about trainers, various training gadgets, and a company that I went to visit up in Chicago this last week named Gennflex, and some of their associated companies, and kind of what I'm working on with those folks. Again, this is an Automation Academy presentation. The Automation Academy is, hold on a second. There we go. The Automation Academy is a website that I put together about 3 years ago, maybe released it about 3 years ago, November of 2021. And it contains a lot of training videos for Allen Bradley, Siemens, Beckhoff, that sort of thing. Has a library of training and technical documents and some software that you can download. We do have a community with some interest groups called IO Central, not particularly active at the moment, would love to get more involvement in that. It is open to anybody who wants to join IO Central. That does not cost anything. The Automation Academy itself, of course, does have a membership fee. So you would need to sign up for that if you want to access the videos and the software and that sort of thing. And we do have these Mastering the Machine webinars about once a month lately, depending on what the subject matter is and what I feel like talking about at any given time. You can check out these two websites for more information on the Automation Academy and some other downloadable material and free information at automationllc.com and the Automation Primer, which is a technical blog that was put out about 10, 11 years ago, has lots of free PLC information, that sort of thing on it. One of the things that I like to emphasize, and it does go hand in hand with what we're talking about today, is unlike most PLC training systems, we do offer a lot more here. There's a lot more to learning industrial automation than simply PLC training. Indeed, taking PLC classes can be pretty expensive in person. Accessing the hardware and the software can be very expensive depending on which brand you want to use. If you want to use one of the major brands that's common in the United States or around the world, unfortunately, that hardware and software costs quite a bit. We do have some tips if you want to get into PLC programming on a simpler level and learn things like Codesys and Beckhoff. Their software is free and will run simulations without any hardware. And we have videos on exactly how to do that at the Automation Academy. But there's a lot more that goes into this. Obviously, in high school, you take a lot of classes on math and writing and reading and lots of other things also. And then if you're lucky, you get into some technical subjects like physics or chemistry, that kind of thing, maybe learn a little bit of logic. And if you have special interest groups in your high school, then you can get into electronics and learn a little bit about electricity. And that is a kind of a gateway into getting into industrial automation. As you go to tech schools and things like that, you may get introduced to things like motors and fluid power. Of course, there's lots of Industry 4.0 or IoT subjects like Arduinos and Raspberry Pis that you can get into inexpensively. But along with that, you also have to learn things about special numbering systems that aren't taught in standard math classes. Things about control systems. I do write books on those subjects. Motion control, that's another thing. Servos and stepper motors, how all that stuff works, as opposed to regular old AC and DC motors that run at a single speed. How do we control speed and how do we do precision movements, things like that. In some of those schools, of course, you'll learn things about computers and coding. As you get more advanced, you may learn some things about machine safety, very important, or personal safety. And then, of course, I have on some of the upper tiers things like PLCs and machine vision, robotics, DCS systems, distributed controls in process, instrumentation, things like that, HMIs, industrial Internet of Things, which is a step above the standard Arduino and Raspberry Pi stuff that you do. How can we apply this to industrial automation? Maybe learn some high-level languages. And of course, nowadays we're getting into artificial intelligence, machine learning, AI, databases, all kinds of things. And then I've put these little question marks at the top indicating that who knows where it goes from here. There are a lot of other subjects, and you need to figure out what those subjects are as you get into them. Anyway, we can help you get into some of those topics if you visit the Automation Academy, and let me know what kind of things you're interested in. You can reach me, of course, on my blog and at my website, automationllc.com, or the Automation Primer. So today's subject, trainers, gadgets, and Gennflex. I'm going to go through a little bit of history here. Back in 2016, 2017, I started building this little mini factory. And you've probably seen things like this if you went to a tech school, built out of extrusion using standard PLCs. You can see here an Allen Bradley PLC. There is a Siemens PLC to the left of it. It's not shown here. There is a little HMI here. I got this from Automation Direct. One of the reasons I chose this is because, again, the software is free. And I'm a big proponent of making sure that you have access to software to practice with. Unfortunately, Allen Bradley's software for the ControlLogix or for their HMIs is definitely not free. You're going to pay more than most individual people can afford for these systems. So I like to find things that are less expensive, which leads into some of these trainers that I've been building and things like that. And that's what we're going to be discussing today. Anyway, that mini factory, I had a few people go through my classes here in Lebanon, Tennessee, and use that mini factory to learn some of the different techniques, very similar to what you would do in junior colleges and tech schools, things like that, even some mechatronics classes. It was pretty successful. Unfortunately, it only existed for about 2 years before a tornado came through my area and destroyed my training facility, and along with it, a lot of these gadgets, and pretty much smashed this factory up. And although I was able to rescue pieces of it, the entire factory itself and all of the things that I put into it, took me about a year to build, are now gone. And I really am not particularly interested in building these larger trainers anymore because they're not movable. That's one thing. And I'm in a little smaller facility here. Now it's a lot harder to put something large like this together and then get people in to take classes. So that's probably the last one that I'll ever have built. In any case, about the same time, I came out with a small plastic enclosure and looked into possibly turning this into a system and marketing it, you know, coming up with all the components. You can see here, this actual training system here, this little high bay system, is down in Miami at a customer's, and they don't use it much. It is a MicroLogix, which is the less expensive register-based Allen Bradley software, and you can get a free version of that software. It ran on the 1100. Unfortunately, both of those two controllers have been discontinued. So once again, if you want to get into Allen Bradley stuff on a very low level, you're going to have to get into the 800 series, which I'm not really a proponent of. It's still pretty expensive, and to have good software, you have to pay somewhere around $500 for the software. So again, not practical for individual people who just want to learn. So I've moved on to some other packages, but I did commercialize this to some degree. I used these Fisher Technique models, which at the time, this one that you see here on the right, this was a color test station, and it sorted these red, white, and blue little modules into these bins. They now have a new version that has 4 bins, but it's over $1,000. It's probably $1,200. And back then it was about $800, which is still pretty expensive. But individual people could probably come up with some kind of a system like this and be able to afford it. It was pretty cool because it had little air compressors, and actually these were air cylinders that you see on here, these little pushers. And the little air compressor, if you wanted to buy it directly from Fisher Technique, was only about 50 bucks. And it had little hoses and solenoid valves. And I built this interface with these cables that you see here, and they could drive either one of these. You would just select the program, and the pinouts were pretty common, and they could either drive this high bay warehouse on the left or this color sorting system on the right. They were the two main things that I put together. In any case, that system, one of the problems that I had with it was that a plastic enclosure was made, was glued together by a local company, and it was kind of hard to judge how long it would take to get the parts, and it definitely did not ship well. You can see here it had a plastic hinge, and I shipped one of these to New York for a potential customer to check out. Didn't work out very well. Even though I packed it well in bubble wrap and things like that, it kind of got flexed and cracked, and did not turn out to be a great design. So I came out with another version in about 2020, and you can see here it had extrusion corners on it, and it was nice. You could get all the parts from some of the local companies around here. But again, rather than having one vendor to put together the plastic box, all of a sudden I had the local extrusion maker, and I had that same plastic company. And I got a lot of the little components here from things like Home Depot, little handles and door handles and things like that. And then all these components that you see to wire in here became another little issue. I collected all these components from, I would say, 6 different vendors, including stripping wire myself and cables. And then I put out a little book here called Building and Wiring Your Trainer Kit. And surprisingly, that's actually sold a few copies on Amazon. I did put an ISBN number on it for people that wanted to build their own kits. They didn't have to buy components from me. As a matter of fact, I don't ship them directly and still don't intend to do all that. But if you wanted to put together the kit yourself, I kind of pointed out where you could get all these different components and what it would take to wire all these together. This was a pretty good system, and I still have several of these. If you can see my picture here, you can see them behind me, built out of the extrusion corners and all that. But it really, for a one-person company, got to be a bit much to go out and find all these components from all these different vendors and put together the enclosure, even just the enclosure itself. It was pretty cool, though. It had some unique features that I'll talk about on the next slide that are also incorporated in my current revision, which is revision 3. So this is revision 3, and you can see here one big difference is there are no extrusion pieces. That's pretty huge because I don't have to have holes drilled specifically in the corners. And there are some other improvements, and these were provided by Gennflex, and we're going to be talking a little bit more about them on the next slide. But what they did is they put together a welded aluminum frame using the same layout that I had before. So the plates for the front still fit. I still use these accessory cables. You can see here some of the items on this table here, some of the old Fisher Technique things. A lot of the bigger ones, either I've sold those Fisher Technique models or they got smashed in the tornado. So they went through the tornado also. But this design is still pretty much the same thing. They did use a bigger mesh you can see on the side than the mesh that I used on revision 2. So revision 2 here, actually you can't see the mesh on the side, but it's much smaller. It's probably 1/2 inch openings on the side. And these are more closer to probably 1 inch openings on the side, but the concept is the same. You can have mesh sides and you don't have to have any fittings. This can be important because if you get a metal enclosure, you're going to drill holes in it. And let's say you already have an enclosure built and then you have to drill more holes. Well, all of a sudden you have shavings in your electronic components. That's very possible for people that don't build panels all the time. And all of a sudden they want to modify their enclosure. And it's really kind of a pain to drill those holes and get those fittings and put them in there anyway. So I went ahead and made these have mesh sides, and people have complained before, hey, they're not finger safe. You know, you can put your fingers in there. Well, this is lab grade equipment. This is not something that you would put in your plant. You don't want to use this for as like a NEMA enclosure, NEMA, even NEMA 12 or NEMA 1. It is not intended to be that. This is purely for training. You need to be able to access the front of the PLC in a lot of cases to push little buttons on it. You need to be able to see the lights on the PLC without opening the door. So that's why this big hole in the top of it is there, so that you can see the display on the PLC, or you know, the little lights on the cards or whatever. And these two in particular, one of the reasons I had to build these is not to sell them, not to market them in any way, but because I needed them for my own classes. And I've come up with a few modifications where I can actually have up to 8 students share these two PLCs. And of course, that limits how many people can use the little buttons on the front, the hardware, but I have an HMI that students can use, and each student can have their own HMI and access their own program. So this is kind of why I've created these, really for my own classes as much as anything. But at the same time, could you use these to put together your own system? Of course you can. You can buy these either directly from Gennflex, or I'm going to put a link where I can drop ship these to you and possibly come up with the components for you also. I haven't figured out how I'm going to do that yet. But the general idea for these is I do have my own training classes. I use these face plates with these e-stops and these little imitation light stacks, which is a pretty common thing to do, but I build them into my trainers because the first thing you're going to learn is auto, manual mode, auto cycle start. You're going to learn safety systems and how a real system starts and stops and creates faults and all that kind of stuff. So I went ahead and had these built the way that I teach the classes. And of course, Gennflex modified this into revision 3. And now we have it down to a system that people can use for their own trainers. So it does have an HTPE, which is high density polyethylene backplane. So you don't have any metal shavings there either. You can mount your DIN rail or whatever to the backplane directly. I did not make a separate backplane out of metal. You can drill and tap all this and leave the front of the enclosure off and wire everything ahead of time, and then put the front on it and wire to the door. And I'm trying to come up with some other ways with Gennflex to make this a little more modular, maybe pre-wire these plates on the front where somebody doesn't have to connect all these wires to these push buttons, because that's problematic too. There's a lot of crimping and potentially soldering. I actually soldered these switches and these potentiometers. The rest of these are all terminal blocks. And we talked this last week when I went up there about, you know, how can we make these like put screw terminals on them or something. And unfortunately, when you go to a screw terminal type light, it gets a lot more expensive. So that's problematic too, because again, I want to keep these inexpensive. So what else we got here? Modular faceplates, as I mentioned. You know, you can either use this HMI type setup like I've got here, that's one plate, or you can use the push button plates like I've got here. It is also assemblable. The advantage of that is, let's say you buy, you know, 5 or 6 of these things, you can ship them all flat in a smaller box. You don't have to be shipping air. And also it's less likely to get damaged if it's not flexing and screws getting loose and things like that. So you can build it yourself. That's the general idea. And I think Gennflex saw the, you know, the promise in this too. So they're also using them for some of their own systems. I saw them, they built a little IDEC trainer of their own, and they're going to maybe use these for some of their own purposes. So who is Gennflex? So this is a little bit of information about them. You can find their information at www.gennflex.com. They build some standard training equipment. And I think right now, a lot of what they do is these little carts the EduCart stem carts, and there are some various advantages to those. And they built their stations on top of these carts. So you can see them here. There's a couple of robots on them. This is a little CNC cutter that they used at a trade show. They were at the IMTS show. And before that, of course, I met them at the Automate show back in May. And then IMTS was in September. And they brought these stations to the IMTS show. And they were advertising also their Gakuto Robotics Club, which is a way to get students, local students, into their training equipment and learn how robots work and how to interface from controllers to robots, things like that. A lot of schools use these VEX systems. So you look at VEX equipment, it's this stuff here. And it's kind of like the Fisher technique that I've been using here. Fisher technique's used widely in Europe, and VEX is used widely in schools here. Both have the same, I would say, disadvantages in that they are plastic, right? They are definitely not very industrial. They don't have a lot of metal in them, but that makes them somewhat less expensive. At the same time, I think this station, which doesn't even have a robot on it, let me see. I've got a picture here I'll slide over. This is some of the things they advertise, and I believe this is their robot system. And you can see here, this is their VEX CTE work cell with a little robot, and it is $2,500. So it's along the lines of these Fisher Technique systems that that I kind of sell and market here also. And you know, it looks like good stuff, but at the same time, I know I'm having problems with, for instance, if these things get damaged in a tornado, how do you fix this little conveyor, right? I have the same problem with my Fisher Technique stuff here. And this robot is not very repeatable, not very precise. And another big disadvantage I saw here, this is much like the Fisher Technique systems where they have a little controller. And unlike Fisher Technique, they do not provide a 24-volt industrial interfaceable version of this. So one of the things that Gennflex did that's kind of neat, but I don't know totally solves the problem I particularly have, is they made a black box interface where the robot at least can talk to the VEX system, to the VEX controller. And they created a variety of drivers and things like that to get in and be able to send commands to the VEX controller from the robot, but it still doesn't solve the problem. How would I easily interface with sensors and things like that, or this light stack, right, from a PLC? And they're really more working on these little stations than they are on the PLC end. I do know they're working with an IDEC PLC and considering doing some training with that. And if I can help them with that, I do a lot of PLC training and obviously write books on PLCs, things like that. So anything that I could do to help them in their goals of creating these IDEC PLC training classes would be great. But it still leaves the same problem of how to use discrete I/O on these fairly inexpensive VEX systems to turn the stack light on and to determine whether a little part is at a certain sensor, right, photo eyes and things like that. So I'm not exactly sure what mode I'm going to get into. If I look back at these models, right, I do have access to these. You can see the cables I plug straight into these boards, and I can access the sensors and things on this. But once again, this particular model here, for instance, the conveyor doesn't roll very well anymore, and I tried to take it apart to fix it, and it was just really hard to put back together again. And it's you know, I would say this thing's $500 and some also, and it can't easily be fixed. You know, once it does get out of whack, you really have to take the whole thing together, and there don't seem to be any instructions on how to put it back together again. So that's problematic, which is why I've come up with, for instance, this little conveyor. Believe it or not, I got this thing. This is a Chinese-made conveyor, and it's used in vending machines. And it was less than $100 for a belt conveyor, right? I bought 3 of these, and it came with this neat little power supply. It happens to be a 24-volt power supply. So I went ahead and kind of broke it apart, printed these legs on a 3D printer, and I'm on my way with coming up with some pneumatic components to be able to push parts off of this. And that's kind of one of my next goals. But meanwhile, Gennflex does build all this stuff. And if I need something new, right, like a troubleshooting trainer, something I'm working on right now, I would definitely use them. And I would advise anybody that sees this video, contact them at gennflex.com and see what they might be able to help you with if you're putting together your own little training system. You know, they're out there fighting the good fight and trying to do this stuff in the US without having to buy all these components from overseas. They're wanting to put together training systems here and make them less expensive, just like I am. So good folks. Like I said, I drove up there this week and talked to Ivan and Mark Giertik, Ivan Kote, Ivan Rulik. He's got a couple last names there. He's from Colombia, and we had some good conversations about how they're doing all this stuff. He's one of the people that put together this black box interface, and was able to watch them, for instance, laser cut a new door for the system pretty quickly. So it gave me some ideas of some equipment that I might want to have around here. But, you know, nice equipment. Again, not cheap. You know, a Yaskawa robot, I was asking, well, do you guys get a special deal on these? And they said, no, it's probably $15,000 for that robot. You know, that's just individual people or even small companies like mine. It's hard to justify putting that together when you can't have one for each student, right? That's ultimately my goal. Is I'd like to have a training station for each student and be able to have them each working on their own projects at a given time. It would be nice if these VEX systems, you know, a system like this had an interface where I could connect it directly to the PLC and let the PLC drive this. But unfortunately, they don't seem interested in giving an interface for other controllers. They want you to use their controller, which is understandable. They're in the business to make a profit. But I would love to have access to things like this little light stack, or, you know, just the robot by itself, and be able to control it and run the motors directly. I may come up with a Raspberry Pi or a Arduino or ESP32 system to do that myself, right? And try to keep it on the less expensive side. But anyway, that's mostly what I've been up to, you know, trainers and gadgets, and went up to visit Gennflex in Chicago. Advise you to get in touch with them if you are interested in purchasing any of these training stations. Again, I don't think on an individual level it necessarily works, but if you're a small school or you work for a small company, they could be very helpful to you. And ask them about the Gakuto Robotics Club that they bring students in and do some training themselves on. They have a nice little facility up there and allow students to come in there and work on some of their equipment. In any case, the next webinar will be probably on November 16th. I may put it off for another week. We will see. But that is the goal, to have it somewhere around mid-November. And I don't know what the topic will be yet. As usual, at this point, I don't plan things very far ahead. May have a guest. That would be awesome. If anybody's interested in coming on and talking about what they do, we talk about all kinds of industrial automation subjects here, PLC programming, training, gadgets, companies, right? I've had a couple guests on the last couple months. So other than that, it's been great seeing everyone, and thank you very much for attending, and we will see you the next time.